Hello and welcome to this presentation on watershed monitoring connections to pollution. My name is Eric Lambert. I'm the Clark County Clean Water Outreach Specialist, and I want to talk to you today about this important topic. It's a great opportunity to complete the connection between scientific research and observation and real-world applications. And of course, while not all of your students will go on to be scientists, they will all go on to be citizens that we hope will have the knowledge to be stewards of their watersheds and their environment. This is a map that shows the monitoring locations from 2017 and with the red dots. Uh, the orange schools are shown there with the school icon. The green dots represent where Clark County has monitoring sites, and the green points represent where the city of Vancouver monitors. So as you can see here, schools have a great opportunity and play a great role in being able to fill in some of the monitoring and data collection gaps that some of the local jurisdictions have. And so it's always beneficial to have extra eyes on the creeks. And you guys really play a big role, especially with FieldScope now up and running, to be able to contribute to our data collection and ultimately help benefit the health of our watershed. As you know, we all do live in a watershed. We all contribute to water pollution, but we also all have the opportunity to help prevent pollution. Um, Going back to this whole idea of connecting what you're doing in your monitoring sites um, with what's going on in the watershed at large, um, always being always being able to reinforce um, what the watershed is contributing, what types of pollutants is contributing, what type of activities are going on with what you may be observing at your monitoring site is really important. I always like to try to convey the idea that water can transport all sorts of things um, into a drainage area, and so what's on a piece of land that might not be near a body of water can easily get to a body of water. Well, you might have seen these storm drain medallions near your catch basins or storm drains, only rain in the drain. We say that because what goes down the storm drain ultimately ends up in our local creeks, rivers, and streams. Sometimes it does stop off at a stormwater facility such as a bioretention cell, bioswales, infiltration ponds, or treatment wetlands, but most storm drains actually discharge directly to streams. It's important to point out that water going down the storm drain does not go to the wastewater treatment plant, and that some pollutants do not get filtered out by stormwater facilities. This is a map that shows what's going on under, under, underground. Basically, this is a map of the stormwater infrastructure. You can see the green lines show conveyance pipes underground. The little green boxes and green circles can indicate inlets or catch basins, and um, the red boxes, for example, over here, um, indicate an outlet where that water is going to be discharged. You can see the path of the flow by following the arrows. And so looking at Sunset Elementary in the lower left-hand corner, you can see there's a catch basin and it flows north, eventually going out toward um, the monitoring location. And so being able to show your students this and share this type of information with them paints a great picture that just isn't able to be seen from your monitoring site, and so can really enhance the depth of knowledge and the lesson plans that you're able to provide by introducing some of this infrastructure, which really goes unseen without a map like this. And at the end of this presentation, I'll be showing you how you can create some of your own maps, so stay tuned for that. Pollution has huge impacts, and it's always important, as I said before, to be able to incorporate um, the real impacts, the why we're doing this monitoring into your lesson plans. Has huge implications for fish. Obviously, salmon protected by the Endangered Species Act are a big reason we do what we do, and what we also recreate, we play in these waters. And there are a number of different wildlife. The majority of wildlife use these waters too. And so being able to tie ownership to our streams and really understand how pollution can have an impact is really important um, to really closing that circle between scientific observation and real world applications. And one great way to uh, reinforce this whole idea is by introducing um, and teaching more about what it goes on in our watersheds. And so the rest of the presentation will be looking at answering two of these questions. What are land uses upstream of your monitoring station? This is an important question to answer because the upland uh, land uses are going to be flowing down into the drainage and past the monitoring sites. And so what's going on in those land uses will be impacting what you may be finding and observing at your monitoring site. And the second question that we'll answer is, where does water go on your school grounds? This really makes it hyper-local and something that students can really start to think about forming some actionable activities around maybe what they can do at school to make a difference. Here's a great picture here that shows Columbia River High School, vast parking lots right beside Cougar Creek. And so by really thinking about where the water goes on school grounds can help students think about what pollutants might be generated on a parking lot or in the ball fields nearby, and what could potentially be going into Cougar Creek, and hopefully some different ways that we could make a positive impact or positive changes. So exercise one, identifying upstream sources of pollution. We have a map here, which is from Clark County Maps Online. I'll show you more about this at the end of the presentation. On the left-hand side of the map, you can see Fort Vancouver High School. Their monitoring site is right at the red arrow there along Burnt Bridge Creek. This map has a few different things happening going on here. One of them is obviously a satellite image, so you get an aerial shot of what the land use is, what's actually happening in the land use. It looks like there might be a water resources layer over there that brings out the color of the streams and the water bodies. And there's also contour lines. So there's a topographical map on here too, which can help determine drainages and just be another thing to introduce into your lesson plans. And so we can use these maps to help identify different land uses. And what we'll go through next are just some of these different land uses that are common in our communities, and talk about some of the pollutants that we may find coming from some of these different land uses. The first one that we'll talk about, residential and apartments. Typically residential uses, maybe medium to high density residential uses, could be about 55% impervious. For large rural lots, it could be a little bit lower, in the mid-20s% of impervious surface. But it's important to look at the impervious surface because ultimately that's how pollutants are conveyed down a drainage system, either through the storm drain or on runoff over impervious surface. And it's also where the pollutants collect typically. So some of the pollutants that we might find in residential or multifamily apartments would include pet waste, yard chemicals, fertilizers, pesticides, herbicides, lawn clippings, soaps, excess water, dirt, and soil, etc. Um, and when you're doing your monitoring, some of these pollutants um, may come up as fecal coliform, nutrients, turbidity, um, potentially temperature could be impacted by increased impervious surfaces. So those are some different things um, that you could be thinking about um, if a lot of the upland uses from your monitoring site include residential and multifamily housing. Commercial, business, and retail is another common one, common land use. As you can see in the map here, there's even more impervious surface than what we'd find in residential, typically in the range of 55 to 70% impervious surface for commercial, business, and retail sites. Many of the pollutants could be similar, including trash and debris, but there are some additional ones, including leaky dumpsters and compactors, chemical containers that aren't stored properly. Fats, oils, and greases is a common one, especially if a lot of restaurants are present, and also soap and different materials that could be from dumping mop buckets, which is unfortunately too common. Also landscape materials, potentially herbicides, pesticides from heavily landscaped areas. Things to look for if you have a lot of commercial and business land uses upstream could be oil sheens, trash and debris, cigarette butts, soaps, and potentially other foamy things, all of which you could note in field scope when you're doing your observations. Industrial manufacturing, typically even more impervious, somewhere in the range of 70 to 80% impervious surface for these type of sites. And a lot of the sources of pollution are similar. Dirt, soil, dust, which could increase turbidity, leaking dumpsters and trash compactors, and also soaps and oil from equipment or leaking hydraulics. So there could be potential for finding sheens or foamy substances. A lot of the pollutants that could be coming from industrial uses could be chemicals that won't be detected unless you're doing highly specialized monitoring tests. But it's always good to be able to look upstream and think about different potential pollutants if you're looking to help come up with some ideas of ways that you could prevent pollution. And just to get kids thinking about their monitoring site, not just as a static point on a map, but in the context of a larger watershed with many different activities going on. Roads, parking lots, again, very similar to some of the other ones that we've discussed. Roads will depend a lot whether it's connected to the storm system. Some of the rural roads are not, but typically in developed areas they are, and parking lots as well. Some of the pollutants you could expect to find, oils and greases from leaky vehicles, brake dust and heavy metals from tires, which could include zinc and copper, trash and debris, and typically sediment and dirt is commonly conveyed along roads and through parking lots. And finally, we'll talk about parks and natural areas. Now, typically, these are definitely can act as benefits to our watershed. They're well vegetated, so typically less than 10% impervious surface. However, depending on how the park is used and where it's located, there could be some sources of pollution from parks. It could be a park that has a dog run in it, which may have more people that aren't picking up after their dogs, causing fecal coliform problems downstream. Trash and debris could be problems. And so while typically parks and natural areas are a great opportunity for stormwater um, to be infiltrated or intercepted, and even to have pollutants be filtered by some of the vegetation there, there is a potential in some cases for those parks to also contain some pollutants. So in wrapping up this exercise, um, it would be great if you guys could create a map or utilize a map um, that shows the upstream land uses on from your monitoring site to really put into context what pollutants might be floating past your site, and also to get an idea of if there are any green spaces that could soak up this water and help it infiltrate. Um, I just think that putting this into the larger watershed context can really enhance your lessons and help to broaden the views of the students to look beyond their monitoring site and put it in the context of the whole watershed. And next you can switch gears to utilize another map which becomes even more localized, and that is the map of your school grounds. And so thinking about where where stormwater runs off from your school is yet another activity that can get kids thinking. Um, this is a map here of the um, the storm system at Skyview High School with Alki and Chinook Elementary just to the west of that. Um, again, you can see the discharge point at the red circle up at the top of the map, um, and you can kind of follow it back, or you can start at the school and see where some of the inlets are, which are the circles or the squares. Follow the arrows along the green lines. Um, these areas which have big chunks of green lines in them are some type of a stormwater facility, typically some way to help some of that water infiltrate to reduce peak flows during heavy rain events. And this map is also really neat because, as I'll show you later, um, Skyview is a really kind of an interesting school and just shows how interesting it is to think about these things on a whole watershed, because a half mile to the south is Salmon Creek, um, but and 139th right here is actually the watershed boundary between Whipple Creek and Salmon Creek. So um, Skyview really sits right near the peak um, of that watershed boundary, actually contributing to Whipple Creek, even though it's very close to Salmon Creek as well. So when you're looking at a map like that, again, some important questions to be asking your students and thinking about, where does the water go on campus? Where are the inlets? This can be seen on the map. Not all schools will have such a detailed map, unfortunately. Um, but sometimes an activity of just going outside and identifying different storm drains around your school can help paint a picture and allow your students to have an activity of creating a map themselves. Thinking about where the final outlet or the discharge is. Again, this is something that is available to schools, or this type of map that you just saw is available to schools in unincorporated Clark County. There are some less detailed maps available to schools that are within the cities, but more on that later. It is important to think about where that water is going and where it's discharging. And then to really be looking at the land use on your campus. What are the sources of pollution that you could be finding? If you have a large parking lot, there's a potential for vehicle leaks and oil drips to be a source of pollution. A lot of schools are used as after-hour dog parks, and so fecal coliform could be an issue, depending on the landscaping. Herbicides and fertilizers could be a source of pollution. Trash and debris, another one. And so thinking about what could be sources of pollution on your campus is another good activity to really start to think about real-world applications and ways that students can become stewards moving forward. That ties into number 4, what can you do to reduce the pollution? Um, there are a lot of different activities and different plans that you can bring and prepare your students for Watershed Congress and and just be thinking about what type of plans that you could have to reduce pollution, whether it's trash pickup is one that is fairly common. Um, but there are some other interesting ones too. The Watershed Alliance is running a program called Don't Trip and Drive right now. So they have these vehicle leak check events as one way to help people identify leaking vehicles and get them fixed. There are some pet waste signs or pet waste pickup stations and trash stations that are available in some jurisdictions. And so that could be another activity to reduce pollution if fecal coliform from pet waste was a common pollutant found on the campus. And there are a bunch of other ideas too. So just to kind of really tie it all together, the impacts of pollution on water quality, um, being able to identify the potential pollutants and really assess um, what the water quality looks like in the context of the larger watershed. It's important to be able to look what's happening upstream um, and compare those to the data results that you're finding in the water. I've definitely seen some incredible presentations at Watershed Congress where students have really done a ton of work to um, understand and develop their research and the monitoring numbers. But then I've seen them be stumped with questions about, you know, what could be causing this, or what do you think might be some of the potential sources of this pollution. So we're really hoping to close that gap and to enhance the holistic understanding of the watershed and how it fits into their monitoring site. And again, from there, it's moving on to finding solutions. We're going to switch gears right now and talk about making maps. And there are a couple places that you can go to do that. The first one that I'll discuss is the Clark County Maps Online, and there's the URL for that. Google Maps is also useful in some applications, and you may need help with creating some of these maps. Don't hesitate to contact me or Rainey if you need some help with a map. So the first place I'll go here is www.clark.wa.gov/GIS/mapsonline. The initial landing page layer is administrative boundaries. There are some interesting things you can look at here. If you haven't explored Clark County Maps Online yet, definitely go down that rabbit hole. There's a ton of information there, and I'm sure there's a lot of really neat activities that you could bring into the classroom. I love maps, and I think it's an incredible way to be able to convey information. So when you arrive at this landing page, I want to make sure that I'm sharing. When you arrive at this landing page, you can first go up in the upper right-hand corner to Map Sites and go down to the Environmental Map Site. And first we're going to talk about how to create a map that shows the upland uses or the upstream land uses of your school. So we'll just use Skyview here as an example. Copy the address. You can find the address of your school, and then you can go up in the upper left-hand corner to find parcel and put that address into the street address. It will find it, and then it will zoom right in. If you didn't want to find it by an address, you can also zoom in and out with your mouse roller or or over here in the lower right-hand corner. But this shows the tax lot for Skyview High School, and and right now we're really just in um, still the administrative layer, so you're just seeing tax lots and not really um, anything else. But when you click over on layers, you see there's three tabs in the upper left-hand corner. If you click on layers, it will give you a layout of the different things that you could be looking at. When you look at under environmental where we are, there is just a ton of things that you could be looking at here. Um, we'll jump down first um, to the very bottom where it says water features and watersheds. You can see here near the bottom, um, there's a watershed and a subwatershed layer. If you click on that box, um, it takes a second to load, and then you can get that blue line which delineates what watershed. And so as you can see, 139th here is the watershed boundary. So to the north is Whipple Creek watershed, and to the south is Salmon Creek watershed. But you can also go one level closer to subwatershed. Um, and from there you can see in slightly lighter color is the boundary for the subwatershed, um, which you can see slightly a um, less thick line. These are the waterways, but the subwatershed you can see it's a little bit easier to see going down in the Salmon Creek. Um, here it says Cougar Creek, and so the subwatershed line is here, and the main watershed line is a little bit thicker right there. So when you're looking at that, that's great to see. But what you really want to see for land uses is you need to see some imagery. So I see here that uh, the school is located in the southern edge of the watershed, and so a lot of the upland uses might be a little bit to the east. We're close to the boundary, even to the east. So what we're going to do here, if you go to the layers section over on the left-hand side, at the bottom you'll see base maps. You can click on the box that says 2016 imagery, and that will put a layer, an uh, aerial photo layer over top of the map. And a neat feature that you can use is this toggle bar here, which will adjust the transparency of that layer, which is helpful sometimes if you want to look, if you have a lot going on or a couple different layers selected. Sometimes it helps to reduce the transparency of the imagery layer, which can be very busy. But in this instance, um, we'll want to have a look at some of the upland uses. And so we can zoom in now and say, okay, just to the immediately to the east of the school, we have residential. It looks like moving further east through the watershed, we do have some parks and some commercial or retail business type of land uses. Definitely some more residential. Looks like some multifamily housing in there too. So being able to observe this and then go back and think about some of the pollutants that can be common from some of these land uses is a really good exercise. Um, just simply creating a map like this can introduce a lot of different lessons and a lot of different brainstorming for um, both potential sources of pollution and then also um, actions or ideas to prevent pollution. Um, so if say you have your map here, you've got it scaled to about where you want it, where you have the whole watershed or a good portion of the watershed boundary um, in the map. Their monitoring site is somewhere um, nearby, then You can go up here to print map. You can title the map. You can write in notes. You can have different sizes. You can have different scales. If you pick current scale, it's pretty much the size of the view right here that you have, and then you create map. And in just a minute, you'll see a hyperlink here that you can click on to then uh, get the map in a printable and downloadable version. Um, and so it's a really neat exercise and a really neat um, thing to be able to do. The legend will expand with different layers that you have selected. So going back to the layers tab, I'm going to turn off imagery again, just to show you different um, a couple of other neat things in the environmental section. Um, they have Endangered Species Act, so you can see species of state concern. And so if you select this layer, you can select each individual species um, to see if it is a species that is present in that stream. There we go. Fall Chinook. You can go to the legend here and see that it's documented that fall Chinook run in Salmon Creek. Just kind of another neat way to be able to tie in real-world applications um, and real-world connections into some of your lesson planning. You can also look at uh, slopes is one. That's not the best one. Actually, uh, soils and wetland inventory is a good one. You can look at water table elevation, which will give you an idea of the depth to water. Gives you those lines um, that show you what the water table elevation is. Um, and there are a number of other different things that you can look at here under environmental constraints or um, habitats. So I just really encourage you to check out this. There's a lot you can do with these maps, and it can be a great way to really enhance and bolster a lesson in class. So we're going to switch gears a little bit here and move over to the other map I showed you, which was of the stormwater infrastructure. So going back up to map sites in the upper right-hand corner, you can go down and select the utilities map site. And it will load up. And so here you have, again, moving over to the left side of the page, um, on the second one down is a stormwater box that can be expanded. There are a couple different options here. There's a storm sewer includes cities simple. If you are in the cities, this would be one that you'd want to look at. If you're in unincorporated Clark County, click on the next one below. And I will show you a little bit about how they're different here. So again, you have seen this map actually in one of the earlier slides in the presentation. It had the imagery on it, but right now it doesn't have the imagery, and it just kind of shows pretty clearly about where the different catch basins are. You can expand this to show you all the different things that are selected, and then if you want to see a legend for this, for example, inlet and outlet, you can expand that on the right-hand side of the label, and you can get a legend. So, square would either be unspecified or catch basin. Circle with a dot is a curb inlet. So you can see some of these things on the school or where they're at on the school. Again, the green lines show the conveyance pipes, and the arrows designate which way the water is flowing. And as you can see up here in the near the top of the map, the red box is the discharge point. Basically, a lot of the stormwater coming off of these three schools is discharging right into Upper Whipple Creek. Um, Again, if you want to add a little bit to it, you can click on the 2016 imagery on the right-hand side, which will just be another way to look at the map and get a perspective of what the land use is in the context of the stormwater infrastructure. Now that's great for schools that are in unincorporated Clark County. Unfortunately, they're not quite as good. The maps are not quite as good in unincorporated, in the cities rather. And so I'll just do, I can do this one. Just gonna look at, use this school as an example out in Camas, part of the Evergreen School District. And it's still loading. And we're going to go back up here. We can unselect the Clark County storm system, and we can select the storm system includes cities simple. And as you can see, it's really just a set of lines, which is not nearly as detailed as what you get with the unincorporated Clark County schools. The cities, I don't think, have all the resources that we have to develop quite the same GIS system. Hopefully more to come in the future. However, the reason why I put my email address up there is that if you are in a school within the city boundaries, and this is a map that you're finding, and it's just not helpful enough, this is what they get for the public view. But here at the county, and I believe at the cities too, we get a slightly more detailed view. Here's an example of Dorothy Fox, also in Camas. And so as you can see, if you were looking from the general public, these green lines would just be those little brown lines. However, we get a slightly more detailed map that does show inlets and some little triangles too that are more visible when the aerial imagery layer is off, that show discharge points. So if you do need a map like this for your storm system, don't hesitate to reach out. It's pretty easy to make one of these maps for your school. Again, it's not perfect, but it does help to create a little bit more clearer picture of where the stormwater is going, particularly underground. And so that's just another thing that we can help you out with. And so that's pretty much how to use Clark County Maps Online. Again, it's a super helpful and useful tool. Obviously, another great mapping site is Google Maps. One thing I like about Google Maps, kind of going back to Skyview High School here, is it's got a great satellite imagery. And so it's also a little bit faster too than Clark County Maps Online because it doesn't have so much data involved with it. But I think that what I like about Google Maps is that once you know your watershed boundaries and have an idea of what the upland uses are, if you want to dig a little deeper and see what those actual uses are, you can hop over to Google Maps, and it's a little bit easier to get an idea of what's going on. So we identified correctly that just to the east of Skyview High School is residential, but further east than that, we said, we think there are some different commercial and business retail type land uses, and we can confirm that here. We can even see what types of land uses they are. There's a storage area, there's a indoor sports arena, there's a Fred Meyer fuel center, there's a ProTech Industries, and so There are some different land uses here that we can get a little bit better picture of and have a little bit more agility with, just moving around and looking at some of the different land uses and some ideas for potential areas for pollution. See quite a bit of bare soil up here, and so perhaps that is impacting some of the monitoring going on in Whipple Creek. Um, so yeah, Google Maps, you're probably a lot more familiar with it. Um, but definitely do check out Clark County Maps online. Highly recommended. And and I think that's what I've got for you today. So again, just to reiterate, it's so important to reinforce the the connections to the watershed connections to your monitoring site. So really looking upstream, looking at those land uses, thinking about what types of pollutants could be generated, and then thinking about what types of things or actions to prevent pollution could be taken, both on the watershed level, but also on your school level. So even pollutants coming from your campus. Um, Thank you so much for listening. If you have any other questions or comments, don't hesitate to reach out to me, eric.lambert@clark.wa.gov. And looking forward to seeing you at Watershed Congress. Thank you.